Happy day to everyone. I am Dr.A.Amutha, Assistant Professor of Physics, the Standard Fireworks Rajaratnam College for Women, Sivagasi. Today we are going to see about defects of polymers and polymer types, which is discussed with this material science and IPR subject. Next, from this video we want to learn about the defects of polymers, classification of polymers, and how to analyze the plastics, elastomers and fibers. Then learn about different applications of plastics, elastomers and fibers. Next, kindly see, defects are presented in the steps. The steps should be placed uniformly, but here not like that. So defects means imperfection is presented in materials, atoms and molecules are not uniformly arranged, that is called as defects. Next, defects in crystalline materials. The simplest defects is just a missing atom. An atom that simply is not presented in the unit cell, that is vanished. In this figure, missing of atom and the position of few atoms are differed. Next, we will see about defects in materials that are most interesting features because properties of materials are differing with respect to their applications. It is remarkable that materials are strongly bonded in regular crystal structures that looks same everywhere if one looks under the microscope anywhere in the material. However, because natural processes do not occur slow enough, a variety of topological defects always exist. These defects can be classified as point defects, line defects, surface defects and volume defects. So, examples of these defects are vacancies, interstitials, precipitates, dislocations, grain foundries and twin grain foundries and also cracks. Next, we can see about defects of polymers. The point defect polymers is different than in metals and ceramics due to chain-like macromolecules and the nature of the crystalline state for polymers. However, point defects similar to those found in metals have been observed in crystalline regions of polymer materials. These include vacancies and interstitial atoms and ions. Chain ends are also considered to be defects in as much as they are chemically dissimilar to normal chain units. Vacancies are also associated with the chain ends. One may also incorporate impurity atoms, ions or group of atoms, ions in the molecular structure as interstitials. They may also be associated with main chains or as short side branches. The surfaces of chain folded layers are considered to be interstitial defects. Similarly, boundaries between two adjacent crystalline regions also considered to be defects. Kindly see the figures how the doping and annealing of materials play an important role to produce defects. In this figure, elastic deformation observed clearly. Next, we can see classification of polymers. The first one is plastic, second one is elastomers and third one is fibers. First we see about plastics. Plastics are the organic materials that can be easily shaped and or molded by mechanical or chemical action with or without the application of heat. A plastic is a permanently deformable material. Polymers belonging to this class of materials may have any degree of crystallinity and all polymer structures and configurations are possible. Okay. Then plastic polymers may further be classified as thermoplastic or thermosetting that we will see later. Next, properties of polymer. Plastic have following properties. Plastics are lightweight materials, that is their densities and specific gravities are low. They have high resistance to chemical attack, that is corrosion. They have good surface finish when obtained from the dyes, and also they have high thermal and electrical insulation. As compared to metals, their strength is low and also have low elastic modulus value. Then as compared to metals, plastic have low softening and thermal degradation temperature. Plastics are poor dimensional stability, particularly in moisture conditions. Plastics are available in different colors as well as transparent form. With respect to metals, plastics have high coefficient of thermal expansion. They are unsuitable for high temperature applications. Plastic can be easily fabricated. There are many plastics with outstanding properties. The fluorocarbons have a very low coefficient of friction and moreover they are extremely resistant to attack by a host of chemicals. Now we can see about applications of plastic polymers, plastic materials. It is used for refrigerator linings, lawn and garden equipment, toys, highway safety devices, and also polymethyl methacrylate is used for lenses, transparent aircraft enclosures, drafting equipment and outdoor designs. Fluorocarbons which is suitable for anti-corrosive seals, chemical pipes and valves, bearings, anti-adhesive coatings, high temperature electronic parts. Polyamides have important applications of bearings, gears, bushings, handles and socketing of wires and cables. Polycarbonates are also used for safety helmets, lenses, light globes, paste for photographic film. The next type is elastomers. The elastomers materials have properties similar to polymers. These materials may be repeated, stretched or elongated and will return to their original condition upon release of the force producing the elongation. They exhibit elastic behavior as compared to polymers which exhibit greater plastic properties. Included in this category are rubber and rubber-like materials. A distinction is made between rubber and elastomers. Rubber must withstand a 200% elongation and rapidly return to its original dimension. This property of a material to recover from elastic deformation is termed as resilience. Next, we will see about properties of elastomers. It must be easily crystallized. We may note that elastomeric materials are amorphous, having molecular chains that are naturally coiled and kinked in the unstressed state. For the coiled chains, chain bond rotations must be relatively free so that they may readily respond to an applied force. To experience relatively large elastic deformation for elastomers, the onset of the plastic deformation must be delayed. This objective is achieved by restricting the motion of the chains past one another by cross-linking. The cross-links acts as anchor points between the chains and prevent chain slippage to occur. In many elastomers, cross-linking is carried out in a process called vulcanization. The elastomers must be above its glass transition temperature. The lowest temperature at which rubber-like behavior persists for good number of common elastomers is between -50 and -90 degrees Celsius. An elastomer becomes brittle below its glass transition temperature. The properties of common elastomers are difficult and of course depend on the degree of vulcanization and on whether any reinforcement used. Natural rubber has an outstanding combination of desirable properties and is still utilized to a large degree. However, the most important synthetic elastomer is SPR, which is used especially in automobile tires reinforced with the carbon block. Next, we will see about applications of elastomers. Elastomers are used in natural rubber, chemical, seals and O-rings, wire and cable, chemical tank linings, high and low temperature insulation, and also tubing for food and used in medical field also. Okay. Next, we will see about thermoplastic elastomers. Thermoplastic elastomers sometimes referred to as an elastoplastics. Sometimes it referred to as elastoplastics. Result from the copolymerization of two or more monomers. One monomer is used to provide the hard crystalline features, whereas the other monomer produces a soft and also give amorphous feature. When combined, these form of thermoplastic material that takes place but properties of similar to the harder and vulcanized elastomers. See the places of chord component domain, that is chain ends, you can check it, and also check soft component segment in thermoelastic elastomers. Next, we see about third type of polymers, that is fibers. Fibers consist of long molecular chains and all the chains are aligned in the direction of length of the fiber. The directional properties are improved by alignment. The strength of fibers are greatly enhanced in the direction parallel to the fiber length. This provides strength to the polymer units. The fiber polymers are quite capable of being drawn into long filaments having at least 100:1 length to a diameter ratio. Some polymers used as fibers such as nylons and cellulose acetate serve equally as well as plastics. Most commercial fiber polymers are utilized in the textile industry, being woven or knit into cloth or fabric. The aramid fibers are widely employed in composite materials. A fiber polymer to be used as a textile materials must have some restrictive physical and chemical properties. Fibers, while is used to a variety of mechanical deformation, example stretching, twisting, shearing and abrasion. Next we will see about the properties of fibers. The choice of method mainly depends upon the properties of polymers, that is heat stability, melting point and solubility in suitable solvents. The thermal properties of fiber polymers are important from the point of view of washing and maintaining in cloths. These properties include melting and glass transition temperatures. Also, fiber polymers must show chemical stability to a rather extensive variety of environments including acids, bases, dry cleaning solvents and sunlight. Synthetic polymers are produced by the following methods: melt spinning, dry spinning and wet spinning. To improve these fiber properties, to increase or decrease resistance, water or fireproofs, etc., chemical treatment is done. The choice of method mainly depends upon the properties of polymers, heat stability, melting point and solubility in suitable solvents. Next, the fibers are used in variety of applications, that is cotton, silk, wool, cellulose, etc. Metallic and ceramic fibers have also similar qualities as that of polymer fibers. However, metallic and ceramic fibers have very high strength and therefore they have many industrial applications. They are also natural fibers. Cellulose fibers are flexible and are strong in tension. Cotton is produced naturally as a plant fiber. However, the synthetic fibers are cheap, durable and have more dimensional stability, and that is why they have almost replaced the natural fibers. And the last, now we have discussed about defects of polymers and types of polymers. There are 3 types we discussed, that is plastics, elastomers and fibers. And then we discussed about their applications and their properties. Okay, thank you for watching this video. Meet you with another title. Thank you so much.